Good morning, you guys. I wanted to go over just a couple problems from 1.4 as I know that the fractions are starting to trip people up just a little bit. I apologize for the lighting. I am still in Colorado, but you get to hear these lovely birds in the background. I just wanted to go over with the most basic and then going up to just a couple more that are a bit more difficult. So let's just start out with the basic fraction equation. So here you have 3/4 times x equals 6. And remember, your goal with any algebra problem is to isolate the variable like we've been talking about. So in order to do that, we want to get the x by itself. And when you have a fraction like this, I know before the ones you were dealing with were just like x over 4, right? So you just multiplied by the bottom. But when we have a full-on fraction, the way we cancel that is to multiply by the reciprocal. So you might want to take a minute if you're taking some notes to just write that down. So multiplying by the reciprocal clears your fraction. And reciprocal is just a fancy name for flip. So I'm going to come over here and all I'm going to do is flip this. Instead of 3 over 4, it becomes 4 over 3. And the reason this clears it, if you were to look, now we'd have 4 times 3 on the top, which is 12, and 4 times 3 on the bottom, which is 12. So the reciprocal always clears things out right here. And now what I wanted, my x, is isolated, so I bring that down. Now I go over here and I look at my 6. Well, in order to multiply my 6 by something, I need to make it by a fraction. I want to make it a fraction itself. And we can make any fraction a whole number by just putting a 1 under it. So I stick a 1 under there and I say, okay, 6 over 1 times the reciprocal of 4/3. Now, if you prefer, you can just multiply across. 6 times 4 is 24, 1 times 3 is 3, and 24 divided by 3 is 8, therefore x equals 8. Okay, you can do it like that, or if you're a fan of canceling early, you could go in here. 3 will go into 6 twice and into itself once. 4 times 2 is 8, 1 times 1 is 1. Okay, so you can choose however way you might like to do that. All right, let's look at another one. Let's say we have 2/5 q equals 1/3. Hold on while I write this down. 2/5 times q equals 1/3. Okay, if we have something like this that we're working with, then we're again wanting to get the q by itself. So I need to take the reciprocal. That would be 5/2. So 5/2. So this becomes 5/2 times 2/5 q equals 1/3. Okay, so this gets this gone right away. And now q equals 1/3 times the reciprocal 5/2. 1 times 5 is 5. 3 times 2 is 6. And q is equal to 5/6. Does that make sense? Hopefully that does. Then I notice we have another, I think we already did the ocean pressure problem. Yes, we did that one. And there's a video there if you want to look for that. Okay, and then if you have one more really long one, let's say you have 7/4, I'll get out of the way so you can see this in a minute, x plus 7/8 equals 7/12. A lot of you have asked me what in the world is going on when I have all of these fractions, right? So we have 7/4 x plus 7/8 equals 7/12. Okay, so what do I need to do here? Well, I want to isolate that variable, right? I want to get the variable by itself. So I should probably look for a common denominator between 4, 8, and 12. And you're probably already good at this, but if you're not, you can simply write out the factors of each, 4, 8, and 12. Okay, so 4 times 1 I know is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. And then 20 and 24. Okay? And then 28. I'm going to stop right there and see if we can get it common. Then you go here. Okay, 8 times 1 is 8. 16 times 2 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 12. 24. Oh, and then I look and I say, what's common between them? 24. So now I know I need to change all of these fractions to be a 24. Okay, so that's my new task now. So I know that I can make this a 24 by multiplying by 6. And if you do that in the denominator, you have to do that in the numerator. So 7 times 6 is 42 over 24, and I attach my r. My variable hasn't gone anywhere. Well, 8, I can make that 24 by multiplying it by 3, right? So if I do that in the bottom, I do that in the top. 7 times 3 is 21 over 24 equals, and then 7 12s, that's just to multiply by 2, because 2 times 12 gives me 24, and 7 times 2 is 14. So now I have an equation I can totally work with because my denominators are the same. So I have 42 over 24r plus 21 over 24 equals 14 over 24. And what you know about fractions is that for a moment, I don't need to worry about the denominator now, right? Because it's common. The r will attach up here with the 42. And so I'm just going to look at my numerators. 42r plus 21 equals 14. Now this looks like a problem I can most likely solve, right? Using inverse operations. So now I'm going to subtract 21 from both sides. Now, if you struggle with 14 minus 21, know that this is an integer situation. So if we do that, we say, okay, just what's the difference between 14 and 21? Well, 7. But I have more negatives than I do positives, so I know my answer is going to be negative here. This is like, say you have $14 in your checking account, and you wish to spend 21. Well, you can't do that, right? That would overdraw you or make you short $7. So that would be a negative 7. So start looking at it in that way. So now we have 42r equals negative 7. We divide by 42. And now we reduce, right? This is, we could divide each by 7. Negative 7 divided by 7 is negative 1, and 42 divided by 7 is negative 6. And my answer is negative 1/6. I'll give you a minute just to look at this problem. Okay, feel free to continue to shoot questions my way that you'd like to see answered. Have a great day.